Hello everyone, we're now going to talk about numerical chromosome changes, and we're going to start off with aneuploidy. So aneuploidy is when there is one or more extra chromosomes or one or more fewer chromosomes. So we're going to see how this process can happen, and then we'll see 3 examples you need to know. So as a reminder, in meiosis, so this is the first steps in meiosis, so this is metaphase 1, the chromosomes have lined up. Anaphase 1, the homologous chromosomes, so one chromosome from each pair goes to the side, so A here, B here, A there, B there. And at the end of meiosis, after telophase 2, we end up with 4 gametes which have half the genetic material of the first cell. This is what happens normally, that's what we saw in the first lesson. Sometimes some chromosomes are not going to be taken to the right part of the dividing cells. So, as an example here, we have the 2 homologous chromosomes which are going to be in the same cell. So after telophase 2 at the end, we're going to end up with gametes with only 1 chromosome and gametes with 3 chromosomes, where normally we should only have 2 in each chromosome. So therefore, if you have a normal gamete which fuses throughout fecund fertilization, so with another normal gamete you obtain a normal 2N cell. If you have a gamete with N plus 1, you're going to have 2N plus 1, and you have N and N minus 1, you're going to have 2N minus 1. So here 5 chromosomes instead of 4, and here 3 instead of 2. Okay, so 3 examples. So this is Down syndrome, and I'm going to take Ardisia. So if you look at pair 21, a bit big, there are 1, 2, 3 chromosomes. So this is a case where there are more chromosomes. So just to fill in a few things. So Down syndrome, DS or DNS, also known as trisomy 21. It's a genetic disorder caused by the presence of all or part of a 3rd copy of chromosome 21. That's what we just saw. So pair 21, there are 3 chromosomes instead of 2. Okay, individuals with Down syndrome have 3 copies of chromosome 21. So their genomes contain 1 extra chromosome, so 47 chromosomes rather than the usual 46. There's an extra chromosome, so therefore the genetic material is different. There's more genetic material, more DNA, an extra chromosome, and that has an impact on the phenotype. So we have symptoms, so the large neck, for example, and quite characteristic shape of eyes for people who have Down syndrome. Another one, Turner syndrome. So if we look at the karyotype, there is only 1 X chromosome, and there is no Y chromosome. So in this case there are less chromosomes than there should be. So you have associated characteristics, so large neck and thicker feet. So Turner syndrome, also known as, so it can be known as 45X, so you put comma and X, so to say that there are 45 chromosomes and there's only one X, or it can also be named 45X O, so 0 for saying there's no Y chromosome, is a condition in which a female is partly or completely missing a X chromosome. Okay, that's for Turner syndrome. Last case. Klinefelter syndrome. So if we have a look, there are where is it? There are 2 X chromosomes and 1 Y chromosome. So this means there's an extra X chromosome. So Klinefelter syndrome, KS, also known as, so this time we're going to name it 47XXY, or it can also simply be called XXY. There's a set of symptoms that result from 2 or more X chromosomes in males. So they're going to have intermediate phenotypes, so they will have a phenotype with some female features and some male features. They are infertile. So there we are, extra chromosome in this case, an extra X chromosome. You've got a back exercise which deals with aneuploidy. Same thing, I will give you the answers to that back exercise. And that's it for this video. Goodbye.